Hello viewers, today we are going to discuss 4 aspects of proteins. Number 1, assessment of protein quality, factors affecting protein bioavailability, digestion and absorption of proteins, protein requirements and deficiencies. Proteins are large, complex organic molecules which are made up of nitrogen, oxygen, carbon, hydrogen and in lesser quantities sulfur because of the sulfur containing amino acids. All proteins generally contain around 16% nitrogen. They play many critical roles in the body. They do most of the work in the cells and are required for the structure, function and regulation of the body's tissues and organs. The functions of individual proteins are varied as their unique amino acid sequences and the complex three-dimensional physical structure. Let us look at some of the proteins and their functions. Number 1, structural proteins. Example, collagen and keratin. They provide structural components. Contractile proteins which help in moving muscles. Example, myosin and actin. Transport proteins. They carry essential substances throughout the body and examples are lipoproteins and hemoglobin. Storage proteins. They store nutrients. Example, casein and ferritin. Hormones. They regulate body metabolism and also the nervous system. Example, insulin and growth hormone. Enzymes. They catalyze biochemical reactions in the cells. Sucrase, trypsin are some of the examples. Then the last important one, the protective function. They recognize and destroy the foreign substances and immunoglobulins are the best examples of these type of proteins. Nutritionally, proteins are classified as complete, partially incomplete and totally incomplete proteins. Complete proteins are the proteins which have all the essential amino acids in the required proportion by the human body to promote growth. Example, egg albumin and milk casein. Partially incomplete proteins. These proteins are partially lacking in one or more of the essential amino acids. Example, rice and wheat proteins. They are deficient in lysine. Incomplete proteins. These proteins completely lack in one or more of the essential amino acids. Example, gelatin and zein which is present in corn. Proteins are further divided into small units what are called as amino acids. They are organic compounds which are attached to one another to form long chains what are called the polypeptide chains. 20 different types of amino acids can be combined in different combinations and proportions to make a protein. Of these, 9 are essential. That is, they cannot be synthesized in the body but need to be provided by the diet. They are phenylalanine, valine, threonine, tryptophan, methionine, leucine, isoleucine, lysine and histidine. The quality of proteins is determined by the composition of the essential amino acids, that is, all the essential amino acids present in the right proportions. When the amino acid composition of the food meals, the amino acid composition of the tissue, then the protein is considered to be of a high quality. Protein quality evaluation aims to determine the capacity of the food protein sources and diets to meet the protein and essential amino acid requirements, that is, to satisfy the metabolic needs for amino acids as well as nitrogen. The term bioavailability encompasses 3 properties of foods that can alter the proportion of an amino acid that can be utilized. These 3 properties are: number 1, digestibility, which describes the net absorption of an amino acid. Number 2, chemical integrity. It describes the proportion of the amino acid that if absorbed is in the utilizable form. Number 3, freedom from interference in metabolism resulting from the presence in the food of substances that limit the utilization of the amino acids. Of these, the greatest source of variation is bioavailability, that is, in most cases, the digestibility of proteins. Assessment of protein quality is done by indirect approaches, that is, in vitro assays and animal and or human metabolic studies, which can be used routinely and safely to predict human proteins and amino acid utilization. Some of these are biological assays, the digestibility coefficient, very often abbreviated as DC. It refers to the percentage of the ingested protein absorbed into the bloodstream after the process of digestion is completed. Now, here you will notice that we take into account the nitrogen intake. As I had mentioned earlier, proteins contain 16% nitrogen. So, if the N value can be calculated, multiply by 6.25 gives us the protein value. So, nitrogen value is an indirect way of assessing proteins. So, in digestibility coefficient, we take it as the nitrogen intake minus the nitrogen that is lost in feces and the endogenous fecal nitrogen divided by the nitrogen intake. Now, even in an absolutely protein-free diet, there is some amount of nitrogen that is lost from the body, and that is called as the endogenous fecal nitrogen. The second very commonly used method is the biological value. It is measured as percentage of absorbed nitrogen that is retained for growth as well as maintenance. Biological value can be defined as the retained nitrogen divided by absorbed nitrogen into 100. A food with the biological value of 70 or more is considered capable of supporting growth. But one thing we need to remember, biological value makes no allowance of losses of nitrogen in digestion. The third important method is the net protein utilization. This takes into account the allowance of losses of nitrogen during digestion. It can be defined as retained nitrogen divided by intake of nitrogen into 100, or simply we can also call it as the multiplied product of biological value and the digestibility coefficient. One of the oldest methods that have been used to assess the protein quality is the protein efficiency ratio. It is defined as the weight gain per gram of protein intake. This has been a very useful method in comparing a new protein source against a reference protein such as egg protein. Greatest error lies in the fact that it takes into account weight gain as the only criterion of protein value. Apart from these methods, there are several methods which have been developed to assess the protein quality. Some of them are net dietary protein energy ratio, net protein ratio, nutrient reference value, which are used to assess the quality of proteins. These methods make sure that the amount of energy consumed is adequate so that the proteins are spared to do their other functions than giving energy. The other two methods that are very commonly used are the scoring systems. One is the amino acid score. It is comparing the amino acid content of a food with that of a reference protein. Hence, egg protein is usually taken as a standard. The amino acids are estimated by chemical, chromatographic or microbiological methods. It is defined as milligrams of amino acid in 1 grams of test protein divided by milligrams of amino acid in 1 grams of reference protein. The other widely used method, recently developed and now universally accepted, is the protein digestibility corrected amino acid score, abbreviated as BDCAAS. As protein digestibility does not reflect the digestibility of individual dietary indispensable amino acids, using a score based on individual dietary indispensable amino acid digestibility is preferred. It is recommended that a revised score called PDCAAS be used, and it is defined as 100 into milligrams of digestible dietary indispensable amino acid in 1 gram of dietary proteins divided by milligrams of the same dietary indispensable amino acid in 1 gram of reference protein multiplied by 100. The second module that we are going to discuss is protein bioavailability. Proteins have multiple functions to perform, and for that, protein-rich foods have to be consumed in adequate amounts. Legumes, milk and milk products, egg, fish, poultry are some of the good sources of proteins. Cereals and legumes are partially incomplete proteins as they are limiting in one or more essential amino acids. But when combined together, the quality of these proteins improve. Cereals can be combined with milk, egg or other sources of proteins, and this is called as complementary or supplementary value of proteins. There are multiple factors which can affect protein bioavailability. The most important one is the gastric pH, which influences the protein digestion. The stomach pH has to be maintained at 2 for the maximum action of pepsin to act on proteins and break them down to polypeptides and amino acids. Whole cereals, legumes, nuts and oil seeds, vegetables contain undigestible carbohydrates, that is cellulose, hemicellulose, galactans, gums, and they lower the digestibility of proteins, thereby decreasing the bioavailability. They do not allow the enzyme to come in contact with the protein deep inside. Another important factor is the trypsin inhibitors. These are found in soybeans, peanuts, and they form inactive complexes with trypsin and does not allow protein digestion to be completed. Another antinutritional factor that is present is hemagglutinins. They combine with the mucosal cells lining of the intestinal wall and decrease the amino acid absorption. Similarly, severe heat processing techniques like toasting, puffing decrease the protein quality. Roundworm infestation interferes with the digestion and absorption of proteins. Infections which cause diarrhea or gastroenteritis interfere with the digestion and absorption of proteins. The third module that we will discuss is the digestion and absorption of proteins. We must remember that unlike carbohydrates, no digestion of proteins occurs in the mouth. It is initiated only in the stomach. The acidic pH denatures the secondary, tertiary and the quaternary structure of the protein, and the HCl converts the inactive form of pepsin, that is pepsinogen, to its active form pepsin. Pepsin acts on proteins to give peptides as well as free amino acids. The incomplete digested chyme leaves the stomach, which is in combination of some undigested proteins, peptides and also some free amino acids. In the small intestine, zymogens get converted into the active form of these digestive enzymes. Hormones, cholecystokinin and secretin help in the release of these zymogens. Trypsinogen gets converted to trypsin, chymotrypsinogen gets converted to chymotrypsin. Similarly, aminopeptidases, carboxypeptidases, they further break down proteins and peptides to free amino acids. Intestinal mucosa contains tripeptidase and dipeptidase. They hydrolyze tripeptides and dipeptides respectively to release free amino acids. If we just summarize, here we can have a look at it. Dietary protein, no digestion in mouth, and it's only in stomach where HCl and pepsin support protein digestion. It denatures and partially hydrolyzes proteins. Predominant digestion will take place only in the small intestine. Then the intestinal lining will absorb the proteins by the active transport. If we go into a little more detail, this diagram will also help us in understanding the protein digestion. Buccal cavity, no protein digestion. In stomach, pepsinogen gets converted to pepsin And in the small intestine, trypsin, chymotrypsin, carboxypeptidase, dipeptidase act on proteins and we get free amino acids. Absorption of these free amino acids takes place in the small intestines. The transport is dependent on sodium. We have to remember sodium is going to play a major role in the active transport of amino acids and also glucose. Animal proteins are more easily digested than the vegetable proteins as they contain undigested fiber and I repeat, do not allow the contact of enzyme with proteins. Liver becomes the main site for the uptake of amino acids after their absorption. They are in turn utilized for protein synthesis, amino acid synthesis. When I use the word amino acid synthesis, we are talking about the synthesis of non-essential amino acids which can be synthesized in the body. They are also used for the synthesis of nitrogen containing compounds like glutathione, carnitine, purines and pyrimidines. The next module is the protein requirement. It is the intake needed to prevent loss of body protein and to allow for adequate deposition or production of protein during growth, pregnancy and lactation. Growth period, pregnancy and lactation are the periods of rapid growth where lot of proteins are required for the human body. The requirement is always set slightly higher than the actual need as some amount of proteins are always used as a source of energy. That is why it is mandatory that the diet contains adequate amounts of carbohydrates and fats as they will provide energy and proteins can be spared to do their other functions. Not all of the amino acids absorbed are available for the synthesis of other vital nitrogen containing compounds. Protein requirements. Protein requirements are based on the quality of the proteins consumed. In India, ours is a cereal based diet and we have a net protein utilization of the average diet as 65 as against that of egg which is given as 100. So with this respect, the average daily requirement in terms of high quality protein for an adult man is just 0.5 grams per kg body weight. But in our scenario with a mixed cereal diet, the NPU is 65 and that is why the safe level that is recommended is 1 gram per kg body weight. However, during pregnancy, an additional 50 grams per day are recommended during the second half of the pregnancy. This takes care of the growth of the fetus as well as the growth of the maternal tissues. Similarly, during lactation, protein requirement is based on the secretion of milk with the protein content of an average of 1.15 grams per 100 ml. It corresponds to roughly an additional 25 grams in the first 6 months and 18 grams during the next 6 months of lactation. The next 6 months of lactation, the protein requirement is slightly low because the infant is expected to start weaning foods and also the mother's milk may not be sufficient to take care of the growth of the growing infant. Infant protein requirement is derived from the milk intake from the mother. Protein requirement of children has been computed based on per kg body weight and also the expected weight gain. The recommended dietary allowances for Indians have been recommended by the Indian Council of Medical Research and these have been revised in the year 2010. Now, if we look at the sedentary man, the requirements are 60 grams. For a woman, it is 55 grams. However, during pregnancy, the requirement increases to 82.2 grams per day. During lactation, as I had said, the first 6 months 77.9 grams per day and during the next 6 months it is 70.2 grams per day. Now infancy is an absolute phase of rapid growth and here the requirement is given with respect to grams per kg body weight. In children 1 to 3 years it is 16.7 grams, 4 to 6 years 20.1 grams, 7 to 9 years 29.5 grams. However, during the adolescent period, that is after 10 years, the requirement for boys and girls will differ. 10 to 12 years, even then it is almost similar for boys and girls. But then in the later part, boys are taller and heavier than girls, and their requirement for protein will be more than for girls. The last module of this class would be protein deficiency. Protein deficiency can occur in all age groups, though it is more common in children and also in underdeveloped and developing countries. Very often, by the time they are adults, there is some amount of adaptation that has occurred. Even then, protein deficiency is seen, and some of the causes are poverty. This is one of the most common cause for protein deficiency, where the buying capacity is limited. Similarly, overcrowded houses and unsanitary conditions are responsible for many infections and infestations, and this can precipitate protein deficiency. Famines, droughts, floods make food unavailable, and that can be one of the causes for protein deficiency. Of course, in the clinical setup, it has often been found that hospitalized patients can set into protein deficiency because their food intake may not be adequate. But compared to adults, children are more likely to suffer, and it is usually classified as protein energy malnutrition. It covers a wide spectrum of clinical stages from marginal deficiency to severe clinical manifestations, that is, the growth retardation. Kwashiorkor is a term used for protein deficiency, meaning the disease the elder child gets when the younger child is born. This is typically seen when the mother's attention is diverted to the newborn, and somewhere the weaning practices, maternal attention to the elder one goes down, and that is where protein deficiency sets in. Very often, it has been found that the energy intake is adequate, but the protein intake is deficient. There are multiple causes when it comes to children when we talk with respect to protein deficiency. Like in adults, poverty again becomes one of the major causes for the low food availability. Buying capacity is low, larger family sizes, and the food gets divided into many people, and that becomes one of the major causes to precipitate protein energy malnutrition or kwashiorkor. Similarly, unsanitary and overcrowded conditions. This is typically seen when there is a mass migration from rural areas to urban areas. Typically, these people settle down in urban slums where the conditions are not proper for human accommodation. Ignorance and lack of education is again an important cause. Mother is illiterate and she does not know what type of weaning foods and what type of food should be introduced to the child. Decline in breastfeeding practices has also been attributed as one of the major causes for protein deficiency. Inadequate weaning, lack of maternal care and attention, and food taboos are again multiple causes. In the Indian scenario again, food taboos are going to play a major role as far as protein deficiency is concerned. Again, maternal malnutrition itself can be one of the major factors which can cause the newborn to be underweight, and the cycle will continue. Infectious diseases, particularly diarrhea, can precipitate protein deficiency. Diarrheal diseases, in fact, can be one of the major causes of deaths in under 5 children. This is predominantly because in infections, their antibody production is less because of protein deficiency, and very often mortality is seen. Intestinal parasites, hookworm, roundworm infestations are very common in children, and coupled with personal hygiene, which is very undesirable, these worms are going to compete with the food that is being consumed by the child, and protein deficiency can set in. The symptoms. The major is the child is disadapted. If we look at the biochemical changes, adrenal does not secrete cortisol. As a result, muscle protein is not mobilized to take care of the amino acid requirement. Plasma amino acid concentration decreases, and there is a parallel decrease in the synthesis of beta lipoproteins. As a result, plasma free fatty acid concentration increases, and it also sets into fatty liver. Apart from this, pitting edema is one of the very visible sign and symptom of protein deficiency. There is water retention, and when pitted, it leaves the fingerprints behind. The child is highly irritable, mental development can be affected, and there is scaly pigmentation. Hair become very thin, sparse, dry, and it can be pulled out easily. In fact, hair can be seen against the light and it appears like a flag sign. There is severe anorexia. There is loss of appetite. Diarrheal diseases, as I mentioned earlier, is one of the common symptoms associated with protein deficiency. Similarly, because the food intake might be inadequate, other nutritional deficiencies are also common. When the child is treated, children with protein deficiency respond dramatically to the treatment. However, the mortality in protein deficiency is very high. Treatment includes higher levels of proteins and energy have to be given to the child to meet the immediate demands, and also it promotes the catch-up growth. The child would have lost so much of time because of protein deficiency that these levels of proteins and energy have to be met so that it promotes growth. It is also important to treat the underlying infection. It could be diarrhea, it could be infestations, but that has to be treated so that the child will be able to make use of the diet that he is consuming. Nutritional status has to be restored. Similarly, adequate hydration becomes very important because otherwise the child can go into renal shock and that can be a cause of mortality. Nutritional rehabilitation has to be ensured, and for all this it is very important to impart nutrition education to the family, but most importantly the mother or the caretaker. So in conclusion, we can say that essential amino acid composition determines the quality of proteins. Protein digestibility corrected amino acid score is the official assay for evaluating protein quality as has been recommended by WHO FAO. Presence of non-digestible fiber, trypsin inhibitors, diarrhea, infestations, gastric pH will all affect the bioavailability of proteins. The recommended allowances suggested are 1 gram per kg body weight, keeping in mind the NPU of 65 in the Indian diets which are cereal based. However, these requirements increase during growth periods and also during pregnancy and lactation. Protein deficiency is more common in children presenting as Kwashiorkor or PEM. Thank you.